All right, so here we go. Who can tell me in your own words how we get vertical asymptotes? We know this one. We know this one. Maya?
By finding your domain and graphing zero.
Exactly. You find your domain, and whatever x can't be is going to be a vertical asymptote. Now, on Friday, we talked about holes. How did holes come into play?
When the top, the numerator can be factored.
And canceled, right?
Yeah.
So we want to always start our problem by factoring everything and seeing if we can cancel. So when I look at number 1A or 4A, I don't think I can do any factoring or canceling here. So there will be no holes. Nothing cancels out of this problem. But there is a vertical asymptote. My vertical asymptote is x equals -3. Because the denominator can never be 0, and if you put -3 in, it would be 0, right? So that's our vertical asymptote. Now, we haven't talked about the horizontal asymptote. Here's how you get the horizontal asymptote. You look at your problem, you look at the highest power of x. Well, in this case, it's plain x. You have plain x on the top and the bottom. And you simply reduce that fraction. So I don't look at the numbers, I don't look at this other stuff, I just look at the x parts. I have 2x over x. What would that reduce to?
2 over 1.
So y equals 2 is your horizontal asymptote. That's what you get when you reduce just the x part of the problem. So graphically, I have a vertical asymptote where x equals -3, and I have a horizontal asymptote where y equals 2. So that's what I have so far in terms of the picture. That's all you have to graph right now is just the asymptotes. Okay, so we have a vertical asymptote. Vertical means up and down. Have a horizontal asymptote. That means sideways.
Do we shade?
We don't shade. We don't do anything.
Just making sure.
We
How do
just
you know
stop.
where to go across?
Horizontal, that's the way.
But it doesn't matter where you go horizontally?
Y equals 2, so you count up 2. Now, let's look at B, because B is a little bit more, has a little bit more going on. So, what do I do first?
A factor, x plus 3, x minus 3, underneath x plus 2, x minus 2.
Very good, Jabron.
I got a deal.
Right. I swear to God.
Okay. I need vertical asymptotes, horizontal asymptotes. Now, you gotta pay attention. Is there a hole?
Yeah, no.
No, because even though we have a lot of factoring going on, nothing cancels out, right? So there's no holes to worry about. But because nothing canceled out, there are going to be 2 horizontal asymptotes. My 2 vertical asymptotes, 2 vertical asymptotes. My vertical asymptotes are where x equals 3 and x equals -3. Where do vertical asymptotes come from? Whatever makes the denominator 0. Whatever makes the denominator 0 is your vertical. Now the horizontal, that's the new piece we're adding today. It's a little bit tricky. Your horizontal asymptote, look at the x squareds in the beginning of the problem. Remember, we look at the biggest power we have. We don't look at the numbers. We ignore the numbers. We're doing horizontal asymptote. We only look at these. So what do we have? Y equals 1. Your horizontal asymptote is y equals 1. So we have 2 vertical asymptotes, at x equals 3 and x equals -3. And then 1 horizontal asymptote at y equals what?
You only have one horizontal asymptote.
Yep. Now, there are some freaky problems, Maya, which we're not gonna do, but there's some freaky problems that on one side have one asymptote and on the other side have another asymptote. But for us, everything will have one horizontal asymptote. Could we ever have more than 2 vertical asymptotes?
Probably.
Yeah, if we had a whole bunch of factors down here, right? Yeah. All right, let's try the next one.
I think I can take this.
Okay, Gibran, let me get it written down, and then I want you to tell me where you think the asymptotes are,
I'd like to
okay?
go to the board and show the class my math.
Okay,
Where's she so for greatness, guys? Just like Nike. Just wait. Just wait. Hold on.
Like Nike.
okay, so Gibran is doing C. The rest of you should be writing down, okay, first of all, any factoring to do? No. So we're ready to start writing down asymptotes.
So, there's no factoring that can go down, so there are no holes.
Exactly.
But the x asymptote will be 4 because positive 4 would make that 0.
So his vertical asymptote,
It's 4 because if you plug 4 in,
Yeah.
oh, because 4 minus 4 is 0. Okay. So then the is that vertical? Yeah, vertical axis is 4, and then to get the y-axis, you have to do the asymptote. Yeah, put y x over get y. So that is 1 and that is 1. So the horizontal axis asymptote is 1. So wait, is that right? Yeah, that's right. So then you get here. Okay, get here. And that's where x equals 4.
perfect.
Then, just go right there. See that, Ethan? That's where the point comes in handy. You know what to do. Get out there, got a little line. That little birdie is called y equals 4.
Okay, there we go.
They're writing me a
Okay.
Okay, let's try the next one. Thank you, Gibran. That was well done. Now, one little comment that I'm going to make about this is, on his picture, he did it perfectly. Over here, he did not. Remember, these are equations. So he can't just say 4, he has to write x equals 4, just like he did in this picture. Similarly, he can't just say 1, he has to say y equals 1, just like he did in this picture. These are equations.
See that, Ethan? See that?
Okay. Okay. No factoring, no canceling, therefore no holes. Madison, any idea where there's either a vertical or a horizontal? You can do either one, I don't care. Vertical or horizontal.
How am I waiting?
Well, what we need to remember is, since you're keying on the 8x plus 6 denominator, you're looking for a vertical asymptote. And what would make that equal 0? (6/8) negative 3/4. So I have a vertical asymptote at x equals negative 3/4. That's what would make this 0. So my vertical asymptote is x equals negative 3/4. Olivia Lillis, how about a horizontal?
You did 3x minus 8.
Not for a horizontal asymptote, no.
No, be quiet. Chill. So, okay, so you did 3x over 8x.
There
and
we
then
go. This is how we find a horizontal asymptote. So where is it this time? Y equals 3 over 8. Very good. So we have one horizontal, one vertical. They happen to be fractions, no big deal.
Yes, we do.
You're doing it one more left.
Miss Ford?
Yeah.
How did you grab that?
My vertical was at -3/4. So here's -3/4. And my horizontal was at 3/8. Okay? Okay, now things are tricky, so I really need you paying attention. I went ahead.
Wait, did you?
I went ahead and when I wrote down problem E, I went ahead and factored the denominator. I always want to factor. Here's the original problem, but I went ahead and factored the denominator. Does anything cancel? Which means, since nothing cancels, I'm going to have a vertical asymptote at -2 and a vertical asymptote at +2. Does everybody see that? So I have two vertical asymptotes. X equals -2, X equals +2. Now, that was easy. It's the horizontal one that is hard. All right, so I need everybody thinking. When I look at the original problem,
Square the top part.
what did you say, Ethan Topham?
0 over 1.
It's 0 over 1. You are exactly right. And it's 0 over 1 because I mean, that's amazing, Ethan. Good work. When I look at the problem, what is the highest power of x that I have? I have x squared, right? But there are no x squareds on the top.
Oh, that's how it works.
You have to look at the biggest power. And if it's missing, you put in 0. So he's comparing this. You can't compare x's and x squareds. That doesn't work. It has to be x squareds and x squareds. So there were no x squareds on the top. There's 1 on the bottom. What is 0 over 1? 0. So your horizontal asymptote is y equals 0, which is right here.
It really is common sense right there.
Wait, so, so this is Precal. Can I just assume that anytime there's like an x squared not on top, the y will be 0?
What you can assume is anytime the power on the bottom is bigger than the power on the top, it wouldn't have to be an x squared.
Oh, so yeah.
Anytime it's bigger on the bottom,
Then y is 0.
okay.
I yelled at him in history last year during and I got a 0 on my paper. Yeah, I got really.
All right. Like exciting stuff. Let's not get distracted.
I'm good at everything.
All right, step 1. Factor.
Did you bring their lunch?
Nothing cancels. Which, since nothing cancels, I will have no holes. However, I will have a couple of vertical asymptotes. I can see right from the get-go that x can't be
-4.
-4, and x can't be 1. So those are gonna be my vertical asymptotes. Where do vertical asymptotes come from? The denominator.
What's the difference between saying it comes from the domain and comes from the denominator?
Same thing, because the domain comes from the denominator too. Yep. Now, let's talk about horizontal. This is another one of the tricky ones. It's going to be y equals 0 again, because like Gibran said, the power on the bottom is bigger. So when you put a 0 on the top here to balance these, you've got to be able to compare x squareds to x squareds. Since there weren't any up there on the top, I said, okay, I got 0 of them up there. So I have 0 over 1, which is 0. So my horizontal asymptote is actually it's the x-axis, so I'm y equals 0.
So every time it's x squared, it'll be 0?
No, girl.
Hey, I'm talking to this boy.
Anytime, listen, this might be valuable to the rest of you. It's something Gibran pointed out. Anytime the denominator has a bigger power than the numerator, it will be 0. So if your denominator power is bigger than your numerator power, you're going to have 0. Okay? Ideally, it will match. These don't match. The bottom's bigger. Okay? Now, my chatty girl table over here. Did you guys hear what I just was telling Maya? What did I say?
Oh, I know what you said.
What did I say, Julia?
That if your bottom denominator is bigger than your top, then it always is 0.
Very good, thank you. You want to say that one more time?
I was solving the next one.
Why don't we say that one more time for the benefit of the rest of them?
So when your denominator is bigger than the top, like what the x is, then it'll always be 0.
Okay, did this group of chatty girls over here, did you get that? No, I was telling Maya. Yeah.
The numerator is a bigger part, or the numerator is a smaller part of the denominator.
Now, take a look at problem G, people. What's different about G?
Oh, the numerator has a higher power than the denominator. Does that make
Exactly.
y undivided?
Now,
Does that make y undivided?
all right,
I thought you said
listen.
on a denominator.
Listen, where's my vertical asymptote in this problem?
X equals 2.
X equals 2. Right? How do I know that?
Because you
The
have to
denominator,
equal to 0.
Javon and Olivia. Now, this time, for my horizontal asymptote, this is the biggest power. I don't have any of those in the bottom. When I try to compare that, I have a huge problem. I have 1 over 0. Whoa, that's not allowed. This problem has no horizontal asymptotes. It's undefined. You can't have a 0 in the bottom.
Oh, okay, that's the whole problem.
Yeah. So, using what we were talking about with Maya earlier, if the power on the bottom is bigger, then the asymptote is always at 0. If the power on the top is bigger, then there is no asymptote. If the powers match, then you just have your little fraction thing that you look at, right? So if the power on the bottom is bigger, it's 0. If the power on top is bigger, it's no horizontal asymptote at all. All right, let's look at H.
Can I use a measure?
No, I think you can wait till the passing period, can't you? Oh my, this is a very ugly problem. Tell me about the horizontal asymptote. There is none. Why is there none?
Is the number on top bigger?
The number, the power. The power on the top is bigger. Now tell me about vertical. What am I gonna have to do to get my verticals? Well, I'm gonna have to factor. Now, kids, do not get crazy. The top doesn't factor, that's a cube. Right? I don't care though about the top because where does my vertical asymptote come from? The bottom. So where's my vertical asymptote?
It's just 2.
X equals 2.
Oh, never mind.
Just X equals 2. Now, let's look at our homework problems. Some of you will struggle with that a little bit. Maybe now it will be a little easier.
Yeah, I get it. So.
So let's look, let's see, that was on page 1. Okay, so who has a question now about our asymptote problems? 58?
Yeah, it's 1.5. Yeah.
Okay. Shh. Tricky, Mrs. Ford snuck a problem in on you. Now this is different. The problem just looks different. Hey, I really don't want to have to keep yelling, all right? I really would appreciate it if we were quiet. This problem looks different. So I'm going to think for a minute. Maybe even get out my calculator and help me plot some points here. So I'm gonna build like a T-chart, because this is just different. This problem doesn't look like all the rest of them. So I'm gonna look at it graphically and see if I can figure out what's going on. So if I put in a 0, what is anything to the 0 power? 1. That's just gonna be 1. All right, if I put in a 1, I'll get 1.5, right? 1.5 to the first. If I put in a 2, I get 2.25. If I put in a 3, 3.375. Let's go the other way. What if I put in a -1? Get 0.67. -2. I'm just typing in, I'm just plugging in numbers, building a T-chart. Okay, that's enough, I think. Let's plot them and see what we've got. Here's 0, 1. These are the positive ones here. What seems to be happening here with these points?
We're going to increase.
They're going up like this, right? Does that feel safe for everybody? All right, now let's see. -1 is -0.67. What seems to be happening this way now?
Going down. Is it a curvy thing?
No, it's not.
This is the picture. and
Wait, so is that
it's-
supposed to be a big curve?
Yeah.
Yeah, it's a nice little curve. It looks like that. Now here's what I want you to think about. This problem does not have a denominator. Would you agree with that?
Yeah.
So I do not have to worry about zeros in the denominator because I don't have one. So there is no vertical asymptote. Because where do vertical asymptotes come from? Zeros in the denominator. If you don't have a denominator, you're not going to have one. However, as I'm heading out this way, what do you notice about these values? They're getting smaller and smaller,
But they're not going to zero.
but they're not going to become negative, are they?
So,
Because if you raise a positive number to a power, it's going to be positive. So while these are getting smaller and smaller and smaller, they're going to stay positive, which means this is acting like an asymptote. This is getting closer and closer and closer to it. So we actually have a horizontal asymptote, and it's y equals 0. Because those points, if you just plot them, will never cross that axis. You can't raise a positive number to a power and be negative. That can't happen. So that it's like 0 is the floor. You're going to get closer and closer to it, but you're never going to go under it. You can't. So we have a horizontal asymptote here. It is not found the same way the other horizontal asymptotes have been found, but it's there. Yeah, your vertical asymptote is 0. Okay? All right. Anybody else have a question from a homework problem? That's a great question. We're going to spend some more time with curves like this. Great question. Anybody else have another one?
oh,
Bryce?
Number 17.
17? Find the range of the function. Y equals 10 minus 6. Okay, Bryce? This question is range, right? Range is hard. Range is the y values. So I'm going to look at a picture of this, and I'm going to graph it just like I did this one. I'm just going to set up a T-chart, and I'm going to plot some points. So let's see. I may not even need a calculator for this. If I put in 0, I get 10. If I put in 1, I get 9. If I put in 2, I get 6. And 3 gives me 1. All right, let me put in some other ones. How about negative 1? What do I get when I put in negative 1? 9. How about negative 2?
6.
And negative 3. Let me go ahead and plot those and see what I've got. There's 0, 10. Yeah. Looks like it is.
So, whenever you don't have a radical or a fraction, then you have to make a T-chart.
I do it anytime I'm not sure what the picture looks like. Now, this is what I got. Does it make sense that that's a parabola? Yes, because squared equations are parabolas.
I forget my calculator in here.
Did somebody find a calculator over there?
Almost did.
Thank you, Katie. Okay. Now, what's the range? The range isn't all real numbers. That's the domain. The domain is all real numbers.
Oh, so they didn't ask for the domain?
This question, I think, asks for range.
That's why.
See, but you said do ask.
Now, wait a second. How high does this picture go?
0, 10.
How low does it go? All the way. So everything less than or equal to 10. So your range is all of the y's less than or equal to 10. And how did I know that? I drew the picture. All right, range is tough. Range is tough. It's harder than domain. Okay, here's what I need for you to do tonight. In your book, look at page 106. I thought I had a sheet for you, but I apparently didn't run them off. So let's do this way. On page 106, 107, and 108 are pictures of the 12 basic functions. All right? Tonight, what I would like you to do, and you can do this on note cards, or you can do it on, just cut up a piece of paper and do it on, pieces of paper. But I want you, on the front of your note card or your piece of paper, we'll just do the first one, which is the identity function. I want you to write identity function, and you don't even need the word function, you can just write identity, and then under it, the equation of it. On the back of the card, or the piece of paper, I want you to draw the picture.
You said on page 106, 108, they have all.
106, 107, and 108. So you're gonna either take a piece of paper and break it up, cut it up into smaller pieces, stop, or use note cards. On the front of the note card, you write identity function and its equation. You can just write identity, you don't need the word function. And on the back, you draw the picture. And there are 12 of them, and you're going to do that for tomorrow. Okay, you're going to have these note cards prepared for tomorrow. Got it?
That's how we do
Yes, if anybody else has a habitat form, I'll sign it.